Welcome, space enthusiasts. Today, we have something truly spectacular to discuss. The James Webb Space Telescope, JWST, has detected a supernova explosion of Betelgeuse, one of the most anticipated celestial events. Stick around as we dive deep into what this means, how it was observed, and what implications it holds for astronomy. Get ready for one of the most thrilling celestial spectacles, the impending supernova of Betelgeuse. Nestled on the renowned shoulder of Orion, this red supergiant star, also known as Alpha Orionis, is on the brink of its cosmic finale. Interestingly, Betelgeuse, once one of the brightest stars visible from Earth, started to mysteriously dim in 2019. This phenomenon was so pronounced that it became the talk of astronomers and skywatchers alike, visible even without any telescopic aid. For a few months, the star's light faded dramatically, sparking widespread speculation: had Betelgeuse finally burned out? When astronomers aimed their most powerful telescopes at this giant, they were astounded to discover evidence of this great dimming. However, just as discussions peaked, Betelgeuse's brightness returned to normal. Now, as it nears the end of its life cycle, the looming question is not just when Betelgeuse will go supernova, but also what impacts, if any, such a spectacular event could have on Earth. Let's dive deeper into this cosmic mystery. Located in the upper right shoulder of Orion the Hunter, Betelgeuse shines as a brilliant ruby beacon in the winter sky. Though it's second in brightness within its constellation to the dazzling blue of Rigel, its impending transformation promises to make it the star of the show. Meet Betelgeuse, a star that captivates astronomers and skywatchers alike with its enigmatic behavior and intriguing name. Known officially as Alpha Orionis, Betelgeuse is famously one of the brightest and most notable stars in the night sky, despite not being the brightest star in its home constellation of Orion. What sets Betelgeuse apart isn't just its luminosity or its striking reddish hue, but its reputation as one of the most accessible and remarkable red supergiants. Located between 430 and 724 light-years away from Earth, Betelgeuse's exact distance remains a mystery, adding to its allure. The name Betelgeuse is derived from an Arabic phrase meaning the armpit of the giant, a nod to its position in the shoulder of Orion the Hunter. This colossal star is about 16 times the mass of our Sun and outshines it by approximately 126,000 times, visible from a staggering distance of 548 light-years. Despite its fiery appearance, Betelgeuse is cooler than the Sun, with a surface temperature of 3,600 degrees Celsius. With only about 200 known red supergiant stars in our Milky Way, Betelgeuse stands out as not just the brightest, but also one of the closest of its kind to Earth. Its size and brilliance make it a prime subject for study, promising to reveal more secrets about the life and death of stars. Imagine a star so vast that if it replaced our Sun, its outer edges would stretch beyond the orbits of Mars, Mercury, Venus, and even encroach upon Jupiter and the asteroid belt. This is Betelgeuse, a titan among stars, with a diameter 764 times greater than that of the Sun. Within this colossal star, the process of nuclear fusion relentlessly transforms hydrogen into helium, releasing immense quantities of heat and light. In fact, Betelgeuse's brilliance would outshine Sirius, the brightest star in our sky, if only our eyes could perceive the full spectrum of its emitted light. Despite this, only about 133% of Betelgeuse's total radiant energy manifests as visible light. Over the millennia, this red giant has been shedding its mass, losing approximately one solar mass every 10,000 years. This mass is cast off into space, forming an expansive nebula that now extends about 30 astronomical units, each unit equivalent to the distance from Earth to the Sun. This nebula is a staggering 250 times wider than Betelgeuse itself. This powerhouse of a star is a beacon of vitality in the cosmos. The energy generated from its core's nuclear reactions travels outward, eventually escaping as photons that journey across the universe. Betelgeuse, a true celestial giant, not only illuminates the darkness of space, but also offers a profound glimpse into the life cycle of stars. In the cosmic theater, stars like Betelgeuse are the main characters in a drama of astronomical proportions. Currently burning hydrogen, its primary fuel, Betelgeuse is on a countdown to a more tumultuous phase. As this fuel depletes, the star will switch to burning helium and carbon. Once helium is exhausted, it will fuse carbon into heavier elements, like iron, a pivotal moment in the life of a star. Iron fusion doesn't produce energy. Instead, it absorbs it, setting the stage for a catastrophic collapse under the star's own gravity. This dramatic implosion triggers one of nature's most magnificent and powerful phenomena, a supernova, unleashing energy equivalent to 10 billion suns. The color and light of a star are telltale signs of its age and evolutionary stage. Younger stars glow blue, indicative of their intense heat, while older stars like Betelgeuse radiate a ruddy hue. Historical observations reflect this transition. Ptolemy, a Greek scholar from 90 to 168 AD, described Betelgeuse's color as ruddiness, whereas ancient Chinese astronomers recorded it as yellow, hinting at previous stages in its stellar evolution. Larger stars like Betelgeuse consume their hydrogen fuel rapidly, shortening their lifespans to perhaps just 10 million years a blink in cosmic time. There's no doubt about it, Betelgeuse is in the twilight of its life, marching inexorably toward its explosive finale. While our Sun, at over 5 billion years old, continues to shine brightly, its cosmic neighbor Betelgeuse is approaching the twilight of its existence. This red supergiant star is poised for a dramatic end, possibly culminating in a supernova. However, predicting the exact moment of this explosive event remains a heated topic among astronomers. Betelgeuse exhibits intriguing cycles of dimming and brightening, with a notable pattern repeating approximately every 5 years. Each cycle lasts around 100 days, during which the star's outer layers expand and contract. This fluctuation affects both the star's size and temperature, leading to noticeable changes in its brightness. In 2019 and 2020, Betelgeuse's brightness dimmed erratically before recovering to its usual brilliance, capturing widespread attention. Some astronomers speculate that these changes could signal the star's impending demise. Despite extensive study dating back to the 1st century BC, the cause of Betelgeuse's unusual dimming remains a mystery. Adding to its intrigue, Betelgeuse was recently observed traveling at a speed of 30 km/s through the interstellar medium. This movement suggests it was ejected from its original home in the Orion B1 association, which includes the stars of Orion's belt. Betelgeuse's dynamic behavior and its cosmic journey continue to fascinate scientists and sky enthusiasts alike. In the realm of astronomy, accurately determining Betelgeuse's true diameter is a complex challenge. This red supergiant is a pulsing star, which means its size and brightness fluctuate over time. Complicating matters further is a phenomenon known as limb darkening. As we observe Betelgeuse, its light diminishes and changes color the farther we look from its center. To define its photosphere, the visible surface of the star, scientists must also consider the circumstellar envelope. This surrounding layer, composed of material ejected by the star, both emits and absorbs light, adding another layer of complexity. The apparent size of Betelgeuse can vary significantly depending on the wavelength of light used for measurement, with diameters differing by as much as 35%. This variability makes direct comparisons challenging. In July 2009, the European Southern Observatory captured stunning images with the Very Large Telescope Interferometer, revealing a massive gas plume extending 30 astronomical units from Betelgeuse. This enormous outflow, one of several observed from the star, was comparable in angular separation to the distance between the Sun and Neptune. Astronomers have identified at least 6 concentric shells of material surrounding Betelgeuse, each a testament to the star's ongoing mass ejections. Unraveling the mystery of how stars like Betelgeuse lose mass in their final stages could provide crucial insights into their ultimate fate. Understanding these processes might help explain the dramatic and tragic end that awaits these stellar giants. The mysteries surrounding Betelgeuse's expansive atmosphere and its complex behavior continue to puzzle scientists. Not only is the star's diameter difficult to pin down, but the exact process by which this red supergiant loses material remains elusive. Understanding these mechanisms is crucial, as they play a vital role in the cosmic recycling of matter that contributes to the formation of galaxies. Fortunately, recent advancements in interferometric techniques may soon shed light on this enigmatic process. In 2019, astronomers used Hubble and other advanced telescopes to observe a dramatic event. Betelgeuse expelled a significant portion of its visible surface in a massive surface mass ejection. Unlike the coronal mass ejections we see from the Sun, which are thousands of times less intense, Betelgeuse's ejection released an astonishing 400 billion times more mass. This colossal expulsion explains the sudden drop in Betelgeuse's brightness observed in October 2019. By mid-February 2020, the star had dimmed dramatically, shifting from magnitude 0.5 to magnitude 1.7. Remarkably, by February 17, 2020, Betelgeuse's brightness had stabilized, leaving scientists eager to uncover the full story behind this dramatic change and what it might reveal about the star's future. For over a week, Betelgeuse's brightness was noticeably fading, but by the fifth day, the dimming seemed to suddenly halt, bringing the dimming event to an unexpected end. Initially, this fading didn't appear to signal an imminent core collapse, as there were no significant changes detected in the star's infrared emissions. On February 24, 2020, a study released on the same day suggested that the dimming might have been caused by large grains of circumstellar dust. This research, using submillimeter wavelength measurements, ruled out dust absorption as the primary cause. Instead, it pointed to large star spots as the main culprits behind the dimming. Further observations revealed a surprising twist. Betelgeuse's luminosity had actually increased significantly. The recent drop in brightness was linked to the discovery of a second dust cloud emerging from the star. By August 30, 2020, a cooler area on Betelgeuse's photosphere was identified as the likely source of this dust. Earlier in June, scientists had speculated that the star's cooling gas might have created this obscuring dust. An independent examination in August confirmed this hypothesis, suggesting that a surface mass ejection could be responsible for the dust production and subsequent dimming. In 2022, the Hubble Space Telescope revealed a stunning scene. Material ejected from Betelgeuse's surface had cooled and condensed into a vast cloud of dust millions of kilometers away. This cloud of debris, once part of the star's photosphere, a region several times more massive than the Moon, had shattered and drifted into space, obscuring the star from Earth. The dimming of Betelgeuse, which began in late 2019 and persisted for several months, was so dramatic that even amateur stargazers noticed it. What's even more fascinating is that after 400 days, the star's pulsation cycle came to a halt. For over a century, astronomers have meticulously tracked Betelgeuse's surface motions and brightness fluctuations to understand its behavior. The explosion's immense force is evident from the damage observed. One theory proposed by scientists suggests that Betelgeuse's photosphere, currently undergoing a period of rejuvenation, is gaining strength as it evolves. This rejuvenation has caused the star's internal structure to vibrate like a bell struck by a hammer, disrupting its natural cycle. These observations provide crucial insights into the aging process of red supergiant stars and their mass loss, shedding light on what happens just before these stellar giants exhaust their nuclear fuel and explode as supernova. When Betelgeuse finally exhausts its fuel and collapses under its own weight, it will unleash a breathtaking supernova. For several weeks to months, Betelgeuse will blaze with such brilliance that it could rival the full moon's glow, becoming a celestial spectacle visible even during the day. So, when might this cosmic event occur? While we can't predict exactly when Betelgeuse will explode, it's unlikely to happen within our lifetimes. It could be tomorrow, or it might be a million years from now. Rest assured, Betelgeuse's distance from Earth means its explosion won't threaten life on our planet. Astronomers estimate that a supernova needs to be at least 50 light-years away to avoid harming life, and Betelgeuse is over 10 times farther than that. In an unprecedented observation, the JWST captured the explosive final moments of Betelgeuse, a well-known red supergiant star. Located about 700 light-years from Earth, Betelgeuse's end was as dramatic as its life, illuminating our sky with data crucial for understanding stellar evolution. This segment delves into the details of the discovery and the role of JWST in this significant astronomical achievement. Betelgeuse has always been a point of interest for astronomers due to its massive size and relatively close proximity to Earth. The star has been under scrutiny for decades, with many predicting its eventual supernova. This segment explores why Betelgeuse has been significant in the study of the life cycle of stars and what its explosive demise can teach us. The JWST's involvement in capturing the supernova provides a perfect showcase for the telescope's capabilities. This section will discuss the advanced technologies employed by JWST that allowed it to witness and record such a distant and momentous event, highlighting its infrared capabilities and the scientific instruments that made this observation possible. The data collected from the Betelgeuse supernova explosion opens new doors in astrophysics. This segment will discuss the potential scientific discoveries that could arise from this event, including insights into the death of massive stars, the distribution of elements in the universe, and the dynamics of supernova remnants. Following this monumental observation, the astronomical community is buzzing with excitement about what could come next. Here, we'll discuss upcoming missions and observations planned by space agencies around the globe, emphasizing how the data from Betelgeuse's supernova will influence future explorations and studies. Explore the fascinating journey from a star's birth in nebulous gas clouds to its explosive end as a supernova. This segment provides an overview of the processes that govern a star's life, emphasizing the factors that lead to different types of stellar ends. Delve into the different types of supernovae and their causes, focusing on type II supernovae, which include the likes of Betelgeuse. Understand the role of a star's mass and composition in determining its fate. Examine why red giants like Betelgeuse are crucial for understanding the universe. Discuss the characteristics of these luminous stars and their significance in the cosmic life cycle, including their role in creating heavier elements. Discuss how infrared astronomy, the key to JWST's success, helps scientists see through dust and gas to witness events hidden from optical telescopes. This segment highlights the importance of infrared observations in modern astronomy. Take a historical journey through past supernovae observations and their impact on astronomy, including the famous SN 1054 that created the Crab Nebula. See how each observation has contributed to our understanding of the universe. Before exploding, Betelgeuse experienced significant dimming, which puzzled astronomers. Explore the theories behind this dimming and how it ties into the star's eventual supernova. Discuss the chemistry occurring within a star like Betelgeuse, focusing on nuclear fusion processes and how they change the star's composition over time, ultimately leading to its instability and spectacular demise. What happens after a supernova? This segment covers the structure and composition of supernova remnants, their role in galactic ecology, and their contribution to the interstellar medium. Explore the potential remnants of supernovae, specifically neutron stars and black holes. Discuss conditions that lead to their formation and their properties. If Betelgeuse were closer to Earth, what would be the potential impact of its supernova? This segment considers the hypothetical scenarios and the actual safe distance that shields our planet from such stellar events. Highlight upcoming telescopic missions designed to build upon JWST's observations, including their objectives and the technology that will drive them. Encourage amateur astronomers by discussing how they can contribute to supernova discoveries and monitoring, including tips for observing and reporting celestial phenomena. Examine how gravitational forces play a crucial role in the life cycle of stars, particularly in their end stages as they collapse into supernovae or other dense forms. Dive into the dynamics of material ejected during a supernova, exploring how fast these materials travel and the forces that propel them. This segment discusses how these ejections contribute to shock waves in space, which in turn may trigger the formation of new stars. Unpack the role of spectroscopy in studying supernovae. This tool allows astronomers to analyze the light from these explosions to determine the composition of materials ejected, offering clues about the star's life and the nature of the explosion itself. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.